Greetings! Here we are again from live broadcasting from Switzerland, from our lab in Ostermundingen near Bern. Today we are going to make again a device sharing setup using our UniFabric software-defined fabric, which is allowing all kind of customers to use their commodity off-the-shelf servers and turn them into device sharing fabrics. So, for those of you who haven't followed the series, just a bit of an overview how UniFabric is working, or basically our appliance. There are actually two ways. There's a hardware appliance, two flavors. There's a hardware appliance, and the hardware appliance has a few fancy tricks on board, like you can connect your legacy storage, maybe SAS, fiber channel, or some NVMe over Fabric, and using the NVMe gateway functionality, you can then port that virtual NVMe LUM as a PCI device to the client. On board also we have support for whatever card supports SRIOV, so that's all your fancy GPUs for Bitcoin mining or whatever nasty things you want to do with them. We have your ASICs you can share. For example, you share some NVMe. You can also load your NVMe offload engine, FPGA, or your ASIC. And on board also we have a software-defined network. That's built-in capability of the PCI switches we are using. It comes with a full DMA engine, so basically you can just use a few cheaper timer cards to build a fancy DMA network. This is, however, at the moment still in a testing phase for the appliance, and for the next 3 months it's still an exclusive for the hardware appliance. So if you're eager for that, you might still buy the more expensive version of our products. And of course we have a lot of support for fabric attached memory. Basically this means we have special JBOFs filled with low latency devices such as Intel Optanes or the upcoming Samsung Z SSD, as well as some DRAM flavors like Microsemi, former PMC Sierra, FlashTech devices. You don't have to use them for fabric attached memory. You can also use it if you build software-defined storage as a very speedy journal or intent lock. I leave this up to you, but fabric attached memory is one of the things that is coming, especially now that we close the latency gap between DRAM and NAND using next-gen technology as Optane or ZSSD. Today we're going actually to use the following demo setup. We use a software-defined version of UniFabric just for the sake that we can really show you that we use the exact same type of Intel reference servers, one acting as a client and one acting as the software-defined fabric. And our setup will be concluding or be an NVMe only one. So we have our NVMe JBOF, which also has a switching engine, so we can put more drives in than we have lanes. There's an oversubscription. And those will be passed to the fabric host, which in turn passes them to the client. You might think this a lot of overhead involved, but I will show you the latency is still stellar. So, enough of the talking, more of the doing, because as in the last video said, we are eager, and Tim and I, our CEO, we have a bet running who first gets the first bag of money from an investor. So I need hopefully to convince you to be one of them, because we already planned our vacation on the Bahamas and stop working as soon as possible. If not, we have to write better software. So I hope my demo is convincing, or convinces you. So sitting here on the UniFabric side, just showing network again. Yes, I'm on the Fabric host, and I have one client node remote in the second terminal window. Well, I already exported the drives. I only have a few leftover Micron ones that I can give away here, which we use for counter testing, and we just use the DRAM part. So we have some reference test how, for example, Samsung Z SSD would perform against an Optane, because we haven't yet got a Z SSD available. On the client side, we already... sorry, typo. Bit nervous. Still thinking about Bahamas. Not gonna happen too soon if I continue like that. We have a bunch of 20 NVMe SSDs which we exported. You see here some DMASC output. So they weren't there, they were just added. So Vscale 08 actually thinks it has an NVMe, it has all the NVMe namespace and everything, but it's just running through non-transparent bridge. So basically this just replicates the corresponding memory buffers that allows us to load the driver, which is kind of fancy. So for our small test, we took all the 20 drives and I just put in 512 byte size, because as I read from the Intel documentation, this is supposed to be the one where the latency is the lowest. So I'm running just 20 jobs, like one for each drive, and let's see how this turns out. Of course, I assured that they're matching the NUMA zone. You see here, it's a node, NUMA node. It's a node 2 where actually our device sharing retimer card is in, because we don't want to go across the NUMA nodes. That adds just unneeded latency. Just once more here. Yeah. So we're on the first FIO. Now it gets boring because you have to wait 60 seconds. So I try to entertain you as good as I can. So you see the IOPS, of course, are not overwhelming, because but it's not the thing we are looking for the most. Also, it's not throughput we are looking for, because you can see that, yeah, it's rather low for attacking a 20 devices. It's latency we look for. Those tiny, nifty, evil transactions like you have on your reader logs of your databases. You have the small page in, page outs of your swap that need to be done in a timely manner. Because if you design your system ready, there will be not too much flooding. So like if you set your VM swappiness to a nice value, you can actually live quite long with a low latency device. As you can see here, we're actually doing pretty good for attacking a 20 drives together. That's values you normally see on a decent DRAM powered, super sized NVMe monster high-end enterprise grade SSD on a single drive, I must admit. And what we have here to do it is just 20 Optane memory, 16 gig devices. You can buy for 50 bucks, and they're generally available. So you have 20 of those. Welcome to the enterprise sector. So enough of the bashing. Let's just go to something more realistic. Let's go. We have just tested 412 byte. Let's check how bad it gets if we put it on a 4K. So again, 60 seconds of your time wasted watching my video, which I'm really proud of. So I see here throughput goes just a little bit up. Nothing fancy going on. Sorry, no big numbers. If you like big numbers, you mostly also say yes to big latency. But still some improvements. because of the bigger block size, of course. Yeah, we have some more latency now, but still not something you would say it's very bad. Now, let's use it a bit more like it's actually used in real life. Let's do some asynchronous I/O. Yeah, that's how we use it mostly inside our appliances. And this is also one of the tricks frequently used in storage subsystems. And you see here there's a bit of bigger numbers coming around the corner. As you can see, latency is pretty damn good. This is also due to the prefetch engine in the UniFabric that now gets active. Yeah, and of course the workload being asynchronous I/O. So now let's just look how we do with sync I/O. But don't expect a miracle to happen, other than it being very steady. Again, the focus here is still latency. And remember, we need to go on the other side through the non-transparent bridge, so our stuff reaches the device. So I see latency matters, especially if you're going to use a fabric attached memory. You're gonna have async sync workload patterns, like whether you use it as a swap device or you're really integrating it into your hypervisor. Your UniFabric and Optane drives are like a good combination for that. So, what else can we run? Let's do something for the guys who want to see big numbers, and that would be big throughput. Let's see if we can serve that. Well, 100 gigs a second is, I think, decent enough, point to point. And remember, we are still running on the software-defined version of UniFabric. We're not using the Enigma 4 ASICs that are located in the hardware version. Now, of course, we have a bit of latency, but bear in mind we're also running heavy throughput now at almost 100 gigs a second. I hope you enjoyed watching this additional video which is created, and it gave you more insight on the capabilities of UniFabric and why it makes a good match for fabric attached memory, software-defined memory. Choose your name you want, but just don't forget to use UniFabric too, and some low latency devices in your stack. I hope you enjoyed, and we're out until our next demo where we're gonna use fabric attached memory on a virtual machine. Stay tuned. Goodbye.